Okay, so now Shinji and I will give you a short summary of the challenge. So the overview of our presentation is as follows. We will start by a brief historical motivation from CHiME 3, CHiME 1 to CHiME 3. Then we'll spend a bit of time looking at environment simulation and microphone mismatches in CHiME 3. This is an extra analysis we made after the last challenge. And based on this analysis, we will then explain what led us to define the CHiME 4 challenge as it was defined, give more details about the different tracks, baselines, then the results, and final discussion. So the CHiME series of challenges started in 2011, and there was a second one in 2013. For both CHiME 1 and CHiME 2, the focus was on real noise backgrounds composed of multiple competing sources. So this was a difference with previous robust ASR challenges, which were made of more simulated noise. So the scenario was domestic noise recorded in a single room with speech from the grid, the small vocabulary grid corpus, or the medium vocabulary Wall Street Journal corpus, which was mixed with that noise using fixed or time-varying impulse responses recorded with a binaural microphone pair at 2-meter distance. The top CHiME 1 system came close to human performance. In CHiME 2, we extended it by having a larger vocabulary or time-varying impulse responses. So this was more difficult, but of course, doubts remained about the use of simulated data. So when we designed CHiME 3 2 years ago, we wanted to have a challenge with commercially relevant scenarios and hardware, more varied noise environments, not just recorded in a single room, real data, that means utterances spoken and recorded live in noise by humans, and close talking mic to create match simulated data in order to possibly expand the size of the training set, because as Michael also pointed out in his talk, if you don't have enough in-domain data for training, then you need some simulation. So here is the hardware. The task that is being considered is ASR on a tablet device in noisy everyday environments. For that, we recorded Wall Street Journal 5K sentences that were spoken by humans in those environments and recorded by a custom array of 6 microphones, which was set around this tablet, plus a close talking mic. So the mics in green, 1, 3, 4, 5, 6 are facing forward, and the mic 2 on is facing
of the challenge success. Of course, number one must be to produce novel and effective techniques. That is but quite difficult for us to control. And establish standard techniques for the problem, more participants, attract community and gain visibility. These kind of things can be a measure for us to do the design the challenge tasks. Of course, these are closely related to each other, but I just listed this kind of the evaluation measure. So for that, we must move to the publicly available data. We still have a little bit licensed limitation, so that is important. And this is quite important. Complete set of the state-of-the-art baseline must be built in the challenge series. For example, then people can only focus on the developing new technologies rather than tuning the system and so on. That might be contribute to produce some people to have a new technology. And design the tasks appropriately concerning scientific finding and real scenarios are important. Place and timing is important, and clear evaluation metric is also important. I also listed several things. participant to report the improvement of each modification to the baseline. That is important. And we asked CHiME for people, the participant to do that. Some people don't want to do that because that needs more experiment, but please, for the community contribution. And increase the difficulty is quite important. But while keeping the, while improving the baseline, otherwise we just lack the kind of participants, so we should do it. In that sense, CHiME 3 to CHiME 4, we did it, and it seemed to be this is very important. And finally, the fairness. We provide we may need to provide some the system to avoid people to overly tuning the test set and so on. So this that we consider, and maybe some of them are really implemented in our next CHiME or whatever. All right. So I would like to thank all the challenge participants, people here, and supporting our challenges, and giving the comment, and all people involved in that CHiME challenge. Thank you very much. Sure.
It's good to know I'm a Skype contact. So it sounded like all the top systems were using system combination. Is that right?
Yes, exactly.
So do you have a sense of what the best single system number was for the challenge overall?
Sorry, that I have to check I cannot say the answer, but this system also providing a single. Most of them are providing single best system, and that's actually very close to the best one. Like as far as I remember, for example, the RWTH system best one is the Padawan system. Sorry, that dear guys did 3.4, right? Our Mars system is also 3.4 or 5 for the single channel, and must be the USTC IFRETEC people also have a similar score, I believe. Yeah.
I'm not maybe of course the exact number, maybe 3.2. If using TSM language model, maybe 3 point or between the 3 point or 4 points.
Yeah.
Between.
Yeah. Thank you.
Can you go back to slide 16 or whatever, some of the whatever analysis?
Okay.
So why is channel 2 80% whatever rate and the rest of it's all?
So channel 2 is at the back, so it would record mostly noise.
Okay.
I'm new to CHiME, so forgive the naivete of the question if it's been answered in previous CHiMEs. So in the training, do you train not just on different environments, but also different SNRs of the same backgrounds? Because 15 years ago, I and some colleagues demonstrated at this crack workshop that actually training across a very wide range, I think we use 60 dB of SNRs, actually improved the recognition on a very simple corpus.
So the SNRs in the test data are real SNRs, of course, because we recorded real data. And there was a range in the order of maybe 10 dB wide. So it's not a huge range, but this is because these are real data. In the training data, the baseline, so there are real training data, similar SNRs. The simulated training data try to reproduce those SNRs. So the range would also be in that order. Then some people did more data simulation with a wider range of SNRs, and yes, they did get improved results.
So I just follow we actually changed in the simulation training data, we actually changed the SNR a little bit, but it doesn't change so much. That means that already this kind of simulation data or real data, training data have a wide range of enough range of the SNR.
Just very simple question. I'm just curious what types of transducer, preamplifier, I mean, device perspective, what types of microphone did you use?
The microphones were cheap, $20 lapel mics. About that, yeah. We bought them off the shelf rather than kind of from suppliers. So they were but very, very cheap lapel mics, which were kind of embedded into this kind of wooden framework. Omnidirectional, yeah.
Last question before the poster session.
So as the world error rate drops to 2%, so I'm wondering how much of this signify the real progress in the far field ASR in terms of the speech enhancement and acoustic modeling? Because I think this is a very restricted task, so the language model, as you use more fancy language model, it really will result in large gain. So probably instead of waiting to next challenge to have more have a task with higher complexity, maybe we can restrict the language model to a simpler version, and then we evaluate all systems from the acoustic model and speech enhancement side. Yeah. So that's my question.
Yeah, this is really what we observe actually. So this is why one of our first priority is exactly what you mentioned. Make the vocabulary part, the language model side, more difficult or spontaneous, or more the larger vocabulary size, or the limiting the use of the language model, and so on. That's we actually decided that is the next target important step of our challenge design.
Okay, so thank you, and we can now move to the poster session that is down there.